Now we're going to do part 2 here. We have a random sample of lifetimes of 13 bulbs. Part 2, calculate the 95% confidence interval for the population standard deviation. Now the sigma is the symbol for the population standard deviation. So we're using this formula here, got from the exam paper. So it's going to be sigma less than, we're getting the square root all across, so it'll be the square root n times s squared over chi squared 1 minus p, and on this side it's greater than ns squared over chi squared p. What else do we need to say here? S squared, yeah, S. What's S? Well, on your calculator, S is the standard deviation, and that'll be sigma x on the calculator. So we're going to enter these 13 values, n equals 13. We're going to enter those into the calculator using the stats function, and then we're going to get sigma x, and that'll be our S that goes in here, n equals 13, and we'll go to the calculator now. So I'm going to enter those 13 bulb lifetime numbers into the calculator using the stats mode. So first of all, we turn on our calculator, and now I'm going to make sure the calculator is clear. So shift, reset, 3 for all, equals for yes, press AC then. Which is the calculator now is in the mode it would be the minute you get it out of the box, so everything is good. So now to enter in this is single variable data, so press menu, scroll over there to 2 for statistics, press equals, and we're going for single variable, option 1. And now we're ready to go. Our first value is 14.7. Our next value is 14.8. Then we have 15.3. Next up 15.6. 15.2. 13.8. 13.3. Now if you've done this for part 1 you wouldn't have to do it all over again, but I'm just doing it, I want to do a better video. 12.6, 14.2, 14.7, 15.1, 13.8 is the 12th value, and the final value 12.9. So that's all the values entered into the calculator. Just adjusting the light there now. So what do we do now? I can press the on key, and now the statistics are still entered in, and now I want to see my statistics, the summary table. So I'm going to press option, and then I'm going to press number 2 there for variable calc, number 2, and then now I have my summary statistics. And you see the one we're looking for there is sigma x 0.92 to 2 decimal places. 0.92 to 2 decimal places. And see x bar there as well, 14.31. So that seems to be right. You can scroll down there and there's SX. We're not getting it for this. We're not interested. That's S hat. We're not using that this time. So back up, sigma x 0.92. So with our calculator there, we just got 0.92. So S, that's what we're concerned with here. S equals 0.92. And we're going to be sticking that into the formula there. Now we're going to be looking up the chi-square tables. That's the chi symbol there. So we're going to need degrees of freedom. Well, n minus 1 will be giving us our degrees of freedom. So that's going to be 13 minus 1 is 12. So that'll be our degrees of freedom. We'll be using those when we're looking up the chi-square table. So now I'm going to do a rough sketch of the chi-square distribution with 12 degrees of freedom. And the chi-square goes something like this. Right. Now we're told that we have 95% confidence interval. So this is going to be a two-tailed test because we're on two sides of it. So this stuff here in the middle has to come to 95%, which leaves 5% to be split between the two ends, right? 5% divided by 2 gives us 2.5%. And in decimal terms, divide that by 100, 1, so you get, so 2.5 divided by 100 will give us 0.025. So now if we take 1 and we subtract 0.025 from it, we're going to end up with, what are we going to end up with? 0.0975. So we'll be looking up these two values on our log table. So now I have the logbook open on the chi-square distribution page, and I'm looking across the row here, 12 degrees of freedom, and our figures we already got there, 0.975, we get 4.403, our chi-squared value here, and when we're looking up, what was the other one? Yeah, 0.025, we have 23.337. Now, and that's where those chi-squared values go into the formula. 4.403 on this side and 23.337 there. So they correspond to this point here on our distribution, 4.4038, and somewhere down here would be 23.337. So all we have to do now is finish off our calculations. N is 13. S is 0.92. We're going to square that, multiply by 13, and divide by 4.4038. We're getting the square root of that. Sigma, that'll be the lower limit for sigma. The upper limit then will be a similar job, 13 times 0.92 squared over our 23.337. So I ran those two bits into the calculator, and over here I got 0.686, etc. And on this side here on the left I got about 1.58. Now you can see they're kind of mixed up. Somehow I've made a bit of a mess of that there, a small mess of that. It should be the other way around. Like sigma, it doesn't make sense that it'd be greater than, that wouldn't make sense. So I'll swap those two figures around, and I have sigma less than 1.58 and sigma greater than 0.69 rounded to two decimal places. Remember we got an estimate from our sample. S was equal to 0.92. So the population standard deviation, we are 95% confident that sigma, the population standard deviation, falls between these two values here. Maybe these guys are in, the wrong. The 23 should have been swapped with the 4.4. Anyway, hopefully that's be some help to you. So that's the answer there. Sigma, we're 95% confident that sigma lies between 0.69 and 1.58.